So a curve has equation f of x equals 4x cubed minus 7x squared plus 2x minus 3, and we're asked to find the coordinates of the stationary points, determine their nature. So if we do indeed have our f of x, now remember f of x, function of x, is essentially our y values, yeah? So you can call it y equals if you prefer. For stationary points, we need obviously the gradient function, so we need to find what we call f dash of x, which remember is essentially what dy by dx is. Okay, so you can call it dy by dx if you prefer. F dash of x is its equivalent. So if we differentiate, that will be 12x squared minus 14x plus 2. And then obviously minus 3 becomes 0. And then for stationary points, we can say that dy dx, or f dash of x, is 0, of course. The gradient will be 0. The tangent will be horizontal. It will be parallel to the x-axis. So we will have 12x squared then minus 14x plus 2 equals 0. So we could look to see if this could be factorized. First thing I would notice though is, can you see they've all got a common factor of 2? So we could scale this quadratic down to make it a little bit nicer, and then we have that there quadratic. Okay, so then when it comes to factorizing it, okay, lots of different ways of course to factorizing. So I'm just going to put here the solution once it's been factorized into 2 brackets. That's what you're going to get. And then of course we can say then either 6x minus 1 is 0 or x minus 1 is 0. So that means x is 1/6 or x is equal to 1. So that's where our stationary points are going to be. Okay, we obviously need to, it says points of course, so we need the coordinate. So we need to work out the y value. So when x is 1/6, okay, y will equal, so remember now y is simply the f of x, yeah? So then we'd sub that in there. So 4 times 1/6 cubed minus 7 times 1/6 squared plus 2 times 1/6 minus 3. So we can type that into our calculator and let's see what we get. So I'll type that in. And we get our answer to be minus 307 over 108, and as a decimal that would be minus 2.843, 3 decimal places. We can put both in there, and of course then when x is equal to 1, y will equal to 4 times 1 cubed minus 7 times 1 squared plus 2 times 1 minus 3. So that works out to be minus 5. Okay. No, sorry, minus 4. I'm doing that in my head, but minus 4 is the actual answer. So we've got stationary points there. Then, of course, they ask us to determine the nature. All right. Well, when it comes to determine the nature, of course, we need to get d2y by dx squared. So we need to get the second derivative. So f double dash of x. Okay, we're going to differentiate this again, and we get, so we differentiate this, I get 24x minus 14. So when x is equal to 1/6, f double dash of 1/6 will be 24 times 1/6 minus 14. Okay, so that comes out to be minus 5. And then when x is equal to 1, f double dash of 1 will be 24 times 1 minus 14. Oh, I can't do maths here. That should be minus 10, shouldn't it? Okay, and then if I put it in here, that works out to be positive 10. Okay, so essentially then, when it comes to doing the, noting then the stationary points, we will have 1/6, that's the first one, and of course y was this value here, minus 307 over 108, and is a, well, because it's negative, it's a maximum turning point. And then the other point then, x is 1, y is minus 4, that is a minimum turning point because it f double dash of x worked out to be positive.